Hello, physics, electric fields, energy stored in capacitors. The question is a 2.7 microfarad capacitor is charged by a battery of 12 volts. Then it is disconnected and connected to a uncharged capacitor or capacitance 4 microfarad. Determine the total energy stored before and after they are connected, and what is the energy change in the system. So this is the question we have to solve this one. And this is we can do this one. So this is the system. This is the capacitor and it is attached to a battery. This is the battery, which is a 12.0 volt, and this is the C1, which is a 2.7 into 10 power minus 6 farad capacitance. So its energy, which is electrical potential energy, which is given by half C1 V square, and which is equal to 1 by 2 C capacitor 2.7 into 10 power minus 6 farad over into voltage 12 volt square, which is equal to 1.94 94 into 10 power minus 4 joule, which is PE before. And now it's connected to a uncharged capacitors. This is C1 and this is a C2. This is C1 and this is C2. This is an uncharged capacitor. Now we have to find the potential energy uh, of the system afterward. So this is before and this is after. So we haven't got the value of C2, we haven't got the value of voltage, we haven't got the value of Q1, we haven't got the value of Q2. But what we know that the charge before, how much is the charge before, total charge? So the charge at Q total is equal to uh, uh, C1V in this system. So C1 is equal to 2.70 10 power minus 6 farad multiplied by 12.0 volt. So this will give us the value 3.24 into 10 power minus 5 coulomb, which is equal to T total. So the T total is will be equal, will split into two, such that the Q total is equal to Q1 plus Q2. So this one, uh, this is another result, Q total. And now this one, Q1. So we can find the Q1. So Q1 is equal to C1V, and V is the same in this one, voltage same on C1 and C2, across C2. So voltage is equal to Q1 over C1. Similarly, Q2 is equal to C2V, so that means V is equal to Q2 over C2. But Q2 is from here, Q2 is equal to Q total minus Q1. So we can use this value here, Q total minus Q1 over C2. This is equation 1 and this is equation 2. So using equation 1 and equation 2, equation 1, Q1 over C1 is equal to Q total minus Q1 over C2. So this is equal to Q total over C2 minus Q1 over C2. This will go on this side. Q1 is to common, 1 over C1 plus 1 over C2 is equal to Q total over C2, or LCM C1 C2, C1 plus C2 into Q1 is equal to Q total over C2. C2 cancel. So Q1 is equal to, this will go over there, Q total C1 over C1 plus C2. So this one, so this expression Q1. So Q1 is equal to Q total C1 over C1 plus C2. If you calculate this one, Q total is this one. We have already expressed this one. So 3.24 into 10 power minus 5 coulomb over capacitance of the first one, 2.70 into 10 power minus 6 farad over C1 plus C2 is a 4.0 into 10 power minus 6 farad. So this will give us a result of Q1, and Q1 is equal to 1.3 1.305 into 10 power minus 5 coulomb. This is Q1. So Q2, we know this one. Q2 is total is 344. So Q2 we can find out. Q2 is equal to Q total minus Q1, which is equal to 3.24 minus 1.305 into 10 power minus 5, which is equal to Q2 is equal to 1.93934 into 10 power minus 5 coulomb. So Q1, Q2 is known. So now we can find out the potential energy afterward. So this will be energy of C1, PE of capacitor C1 plus potential energy of C2. So this will be equal to into half into Q1 square over C1 plus half Q2 square over C2. So if potential energy after, so this is equal to half into Q1 is this one 1.305 into 10 power minus 5 whole square over 2.7 into 10 power minus 6 plus Q2 1.934 into 10 power minus 5 whole square over uh, capacitance 4 into 10 power minus 4 minus 6, 4 into 10 power minus 6, and this energy is equal to 7.83 into 10 power minus 5 joule. So PE after is equal to, uh, previously we have in the form of 10 power minus 4, so this will be 0.783 into 10 power minus 4 joule. So this is after, and the change in energy, the delta PE, PE after minus PE before. So this is equal to 0.783 into 10 power minus 4 Joule, take away 1.94 into 10 to the power minus 4 joule. So the answer is minus 1.16. 10 power minus 4 joule is the change in energy, electrical potential energy. So it's reduced. So this is the answer of the question of this question. Two capacitors charged and disconnected, and what will be the stored energy? The stored energy and what is the difference? And difference will be negative. So this is the answer of this question. Solve this one, and then first find the energy, then total charge, then express total charge will be converted into Q1 and Q2. Total charge is conserved, and we will find the voltage. Voltage is same from the condition Q1 plus Q2 is equal to Qt. We will express Q1 and then express Q2, then use the formula for charge energy Q1 half Q1 square over C1 square. Similarly for second uh, capacitor, and then find the value of the afterward and then difference.